Okay, now let us solve this problem. It is a tabular representation is given. We have to find out the given sample. What is the meaning of these things? Again, I'll repeat it. M by Z means mass of the ion divided by charge of the ion. So it is M by Z ratio, and this is a relative abundance. M plus dot plus P. M plus dot peak, M plus dot plus 1 peak, and M plus dot plus 2 peak. These are the 3 peaks given. Seeing this, we have to find out the sample that is given. Now, M by Z ratio of M plus dot peak is directly proportional to the molecular weight of the compound. Now here, the first thing we have to do when we get this, we have to find out whether nitrogen is present. Chlorine, sulphur, bromine, hydrogen and carbon. These all things we have to find out. Let us first find out whether nitrogen is present. For nitrogen to be present, the molecular weight or M plus dot peak must be odd. Here you can see it is an odd number. If the molecular weight or if M by Z ratio of M plus dot peak is odd, it means nitrogen is present. Now let us see whether chlorine is present. To find out chlorine, sulphur or bromine, the same formula applies. That is relative abundance of M plus dot peak and M plus dot plus 2 peak. Their ratio we have to find out. If the ratio we get 3:1, it means chlorine is present. If we get the ratio as 100:4.4, sulphur is present. If the ratio is 1:1, bromine is present. Let us see now. Relative abundance of M plus dot peak is to M plus dot plus 2 peak. M plus dot is 100 and M plus dot plus 2 is 32.1. Just take the round figure 30. When we do this, we get 3 3s are 9. So our ratio 3 1s are 3 3s are 9. So our ratio will be 3:1. If the ratio is 3:1, we can say chlorine is present. If we get the ratio as 3:1, sulphur and bromine are ruled out. So we need not do any calculation any further. We can just say chlorine is present. So we got two things, that is nitrogen and chlorine. Next, these two things have been ruled out. Now let us do hydrogen. Find out first number of carbons before going to hydrogen. The number of carbons here, since nitrogen is present, the formula will change a little. It will also take into account the contribution of nitrogen atoms. Number of carbons present is equal to relative abundance of M plus dot plus 1 peak minus contribution of nitrogen atoms. Okay. Now this is a fixed value of 0.38 divided by the same thing 1.1. Now here relative abundance of M plus dot plus 1 peak is how much? 9.4. And contribution of nitrogen, it is 0.38 minus 0.38 divided by 1.1. What we get is 8. So how many carbons are present? 8. Now we have got nitrogen, we have got chlorine, we have got carbon. Now we have to find out hydrogen. To find out the hydrogen, our formula is, to find out is molecular weight minus atomic weight of carbon into number of carbons minus atomic weight of nitrogen, atomic weight of nitrogen into number of nitrogen, that is 14. We have to take nitrogen 14 into 1, then plus atomic weight of chlorine into number of chlorines present. So molecular weight is 151 minus 12 into number of carbons is 8 minus 14 into number of nitrogens is 1 into 35 into number of chlorine is 1. I will write nitrogen here and chlorine here. Okay, number of nitrogens, number of chlorines, they are 1 1, so I have written it here. So our answer is 151 minus this whole thing. When we simplify, we get the answer 145, which is equal to 6. So number of hydrogens that we have got is equal to 6. Now we have carbons, we have hydrogens, we have chlorine, we have nitrogen. So our molecular formula, we can say that it is C8H6NCl. Okay. So let us find out the saturation. For finding out the saturation, we use the formula of dBe. Use the dBe formula. dBe double minus hydrogens divided by 2 minus halogens divided by 2 plus nitrogen divided by 2 plus 1. This is our general formula to find out the dBe. So carbons are how many? 8. Hydrogens are 6 divided by 2. Halogens are 1 divided by 2. Nitrogens are 1 divided by 2 plus 1. Minus half plus half cancels out. 2 3s are 6. 8 minus 3 plus 1. We have the answer 6. So our dBe is 6. Which means when we see dBe as 6, if dBe is 0, we say that there are no double bonds present. If dBe is 1, we will say that there is one double bond present. Now here it is showing 6 as the dBe, which means we will say that double bonds are 6. Okay. Now in normal, now this may be a cyclic compound or may be acyclic compound. We do not know that. Now in a normal hexane, now cyclic molecule, if it is a cyclic molecule, we consider 6. Let me take, it may be a benzene ring. Now it is 6 double bonds we are saying. Here when we draw, it is a 3 double bond. We say that it is having 3 double bonds in benzene, but when we draw the whole of the structure of benzene, it means it is equivalent to 4 dBes. Okay, so here we are having the number 6. We have found that benzene is present, therefore it is having 4 double bonds. We say that 4 dBe is present in one benzene ring, but still 2 dBes have to be adjusted. We have not adjusted 2 dBes here, so we assume that one benzene ring is present, due to which our 6 carbons are adjusted, but still 2 carbons are remaining. Now how do we adjust those 2 carbons? And in this benzene ring we have 6 hydrogens, so 6 hydrogens are also adjusted, but still our 2 dBe, N and Cl is still balanced. We have to balance N and Cl. Now N and Cl, maybe a chlorine group is attached. If one chlorine is attached, 1, 2, 3, 4. So one hydrogen has come out. C6H6. Okay, benzene ring, we have attached one chlorine, so one hydrogen has to be removed. We got one hydrogen, and here there are 2 carbons. So we are having 2 carbons. Now chlorine is done. But nitrogen is not done. So we have one nitrogen and 2 plus 1, 3 more atoms. Now we have to adjust this. Now let me take, can I use this carbon with nitrogen like this? Yes, I can. So I am getting cyanide. Now what is remaining? One carbon and one hydrogen. I have got a cyanide group. Cyanide group contains triple bond. One triple bond is 2 dBe. 2 dBe. Now, three double bonds with the benzene ring is 4 dBe. 4 dBe plus 4 dBe is 6 dBe. So our dBe is satisfied. We have one C, one H. If I attach this CN group here, I am left with one C and one N. I can attach CN, CH here. One H I will remove and I will get CH2. But this will be an unstable compound. This is not possible. So what we will do? We will try to adjust this CH2 here. Can we adjust it here like this? CH2. It is 1, 2, 3, 4. Yes, we can do it. So I will put CH2, single bond C, triple bond N. So let us do the namings according to IUPAC system. Here you can see it is cyanide. So you can just write down cyanide. Now this is your base. Base here is benzyl. It is attached to chloro. So chloro. Now chloro is at para position 1, 2, 3, 4. It is at position 4, ortho, meta, para. So it is para. Parachlorobenzyl cyanide is the name of this compound.